the panel. So maybe we could proceed with the next session, which is our testbed panel. And I'm delighted to introduce the moderator for this panel, who will be Professor Dimitris Pados. Professor Pados received the diploma degree in computer science and engineering from University of Patras in Greece and the PhD degree in electrical engineering from the University of Virginia. From 1997 to 2017, he was with the Department of Electrical Engineering at the State University of New York at Buffalo as an assistant professor, associate professor, full professor, and Clifford C. Furness Chair Professor of Electrical Engineering. He also served as an associate chair and was appointed chair of the Department of Electrical Engineering. In 2017, he joined Florida Atlantic University at Boca Raton, Florida, as the Smith Eminent Scholar Professor of Engineering and Computer Science and Fellow of ISENS. At Florida Atlantic, Dr. Pados established and directs the FAU Center for Connected Autonomy and Artificial Intelligence that opened its doors officially in March 2021 and carries out research in the forward-looking areas of networked AI and connected robotics. I will not go over all the accolades of Professor Pados because they are many. Notable distinctions was the IEEE Transactions on Neural Networks Outstanding Paper Award in 2003, the 2010 Best Paper Award, the 2014 Best Globecom Award, and many others. So with that, I would pass it over to Professor Pados to introduce our panelists for today. Professor Pados.
Thank you, George, very much. Great to be with you today, and great to be virtually back in Buffalo. Most importantly, it's great to be with our 6 distinguished panelists today to discuss testbed sharing and federation for wireless research, opportunities, challenges, and what lies ahead. I know we're a little bit behind in time, George, right? Maybe 10 minutes or so, is that correct?
Yes, that's right.
Okay, so let's start really quick with our panelists. From the left to the right on my screen, I have Professor Mohammad Patwary, who is the director of the Center for Future Networks and Autonomous Systems at the University of Wolverhampton. He's a research lead for the 5G Connected Forest project that aims at accelerating the visitor economy in the Midlands of UK. He was also the principal architect for a large-scale 5G testbed in the UK to accelerate digital productivity and to develop urban connected communities. And his current research interests include intelligent and autonomous systems, wireless communication systems design and optimization, future generation of cellular network architectures, and business modeling for the data economy. Mohammad, thank you for being with us today very much. Next to Mohammad on my screen, at least, I have Ivan Seskar. Ivan is the chief technologist at WinLab, Rutgers University, and the program director for the Cosmos project that is responsible for the New York City NSF power deployment. He was the PI of the NSF Genie wireless project, PI for the NSF Cloud Lab, project manager for all 3 phases of the NSF supported orbit testbed project, and Ivan is the co-chair of the IEEE Future Networks Testbed Working Group. Next to Ivan, I see on my screen Casey Wang. Dr. Wang is a Howe Endowed Chair in Collaborative Computing and Professor of Electrical and Computer Engineering at Clemson University. And Casey is also the Associate Director of Research for the Watt Family Innovation Center. He has been a PI and co-PI for a number of NSF projects in wireless and wired networking and cloud systems, including NSF Genie, Cloud Lab, and Fabric. Casey, great to have you here. And we also have with us Professor Serge Fdida, Serge is a professor with Sorbonne University, and his research interests are related to the future internet, as well as the design of federated testbeds to support experimentally driven research. He has been pioneering the European activity on internet test platforms. He's a founder of the ACM Connect conference, a co-founder of the Cosmos company, QOSMOS, Cosmos company, and he was the vice president for international development at Sorbonne University. Thank you, Serge, for being with us. And we also have with us Tommaso Melodia. Tommaso is the William Lincoln Smith Professor with the Department of Electrical and Computer Engineering at Northeastern University and the founding director of the Institute for the Wireless Internet of Things. And he's the director of research for the PAWR Project Office. He's an IEEE fellow and recipient of the NSF Career Award, and his research focuses on modeling, optimization, and experimental evaluation of Internet of Things and wireless network systems. Tommaso, thanks. Good to see you here. And
great to see you, Dimitris.
Yes. We also have with us Professor Hongwei Zhang. Hongwei is a professor of electrical and computer engineering at Iowa State University. And as you saw in his presentation, his research investigates modeling, algorithmic, and systems issues in wireless sensing and control networks with applications to connected and automated vehicles, AR, VR, smart agriculture. He is leading the $16 million project ARA on rural broadband research. So without any delay, let me say that we are breaking this panel activity into 3 parts, I say 3 pieces. Each one of the panelists will have in the first part an opportunity to make a 5-minute introductory presentation. Then in the second part, we're going to address some questions that come from the workshop organizing team. And at the same time, we'll be collecting questions from the audience. The last third part of the panel will be devoted directly to responding to questions from the audience. So let's start maybe right away. And Mohammad, I'm wondering, what are your thoughts? You have like 5 minutes to give us some sort of introductory presentation, your comments about testbeds and what you see there in terms of challenges, opportunities, and the future ahead.
Right. Thank you, Professor Pados. I'm lucky to talk about that as a first speaker. I know all the other honorable speakers, they'll be sharing similar kind of thing, but I have green field to talk about, right? So if we talk about testbeds, especially for telecom, there was a time, if you look at the generations starting from 2G, we used to use spectrum. It used to cover quite a wider area. At the same time, in terms of applications, we have just voice application at that point or SMS. We moved on. I remember in 2001, I was teaching in the class, 3G telephone will be coming and we'll be having access to internet from our mobile phone. And literally out of 60 students, and the 2 students, they were surprised, why you have to use internet in your mobile phone? At that point, we will be using a mobile phone. We don't need to do that, use a mobile phone like the way we used to do it. We'll be looking at the picture. Then who will be using video call? That is the kind of question students used to ask. It is kind of behavioral change. So when we move to 3G, we have one of the key selling point was a video call at that point. And then, of course, voice and data was surplus items from the user's perspective. Since we didn't target most of the particular user group, for example, use cases, we didn't understand at that point what to be the cases we are going to use video calls, why it is important for the user group. We did not have better understanding of that user behavior. And eventually 3G was not successful. from that failure, we have learned that really, if we want to go to the next generation of the network, we need to understand behavior of the user group first, at the same time, the network's behavior. We took that forward, moved down to 4G. We adopted some of the things. For example, we are going to put more than one antenna. This is how we're going to increase capacity. This is the kind of users, for example, if it is internet, we need to beat some of the other internet access people can have from their home. So we need to compete with this kind of associated equivalent applications to have better user experience. We had quite a different kind of learning, of course, then we moved towards evaluation, like for LTE, LTE plus, those kind of things. The whole journey from 1G, 2G, 3G, 4G, we have quite a lot of learning from network perspective. At the same time, from user and use cases perspective. So up until 4G, we managed to do quite a lot of new technology. This is fine. But as soon as we have 5G, we have bigger pipe. We don't know what we're going to do with this big water, with this bigger pipe. A lot of things keep coming. What are we going to do? So Testbed will help us to understand them better. It is how we're going to manage the network. What are the kind of possible use cases we can think of? This one, so this is the facility that we, before we deploy, let's have a better understanding from the testbed. That's the ambition. Second, when we talk about what we expect, not just technological, lab-based experiment, we need to go bigger. We need to look at scalability of that particular network in terms of network operations, all the challenges like deployment, it could be security, it could be resource allocation, all of them. But at the same time, we need to understand user better. So when you have AR, VR application, we don't know how many different kind of applications that can go, but we're learning it now. IoT was kind of applications, I'm talking about 20 years ago, people were talking about sensing, but IoT plays bigger role now. So Testbed can facilitate this kind of scalable testing. Now, if you really want to go towards 5G and beyond that, the use cases of this kind of wireless connectivity is changing. So many variety of applications we are talking about, collecting data, AI, we are going to build. So we need to have real-time data, real-time learning, and real-time high volume of data access and decision making. Now, we cannot do that into one single testbed. So literally, we need to think of how we can make it scalable. So at that point, we think of, can we share our resources? So if you do want to share, do we have the right kind of API? That's what me and Ivan, we are working with Testbed working group to understand a different kind of reference model of this kind of sharing. Now, having this kind of sharing is supposed to have some kind of agreement. To have this kind of agreement, we don't know. Everything is actually blank canvas. So we need to understand how we can federate all of this kind of test beds so that we can have scalable testing, understand network behavior, understand user behavior, and of course, all the other associated things to enhance better user experience. So that's our understanding. So the challenge, if I say that, in my talk, I was talking about even the base station 2 operator, they want to share. They don't even listen to or sit onto the table. So putting all the stakeholder into a trustable table for discussion is one of the bigger challenges, I would say. At the same time, from IEEE, ITU, and FC, we are working together with our team to see if we can come to a reference model. That would be the future we're thinking of. So we made some progress into that discussion. I'm sure Ivan, in his turn, will be sharing some of these experiences. That's how far I can tell you, Professor Pados.
Thank you, Mohammad, very much. Thank you. Yeah, Tommaso, would you like maybe to add a few things and give us your introductory comments? A few minutes, maybe 3 or 5 minutes, if possible.
Absolutely. Let me just see if I can share my slides. Can you see my slides?
We can see your slides very well, yes.
Excellent. All right. Pleasure to be here today. So as Dimitris kindly mentioned in the introduction, have been involved with the PAWR program, Platforms for Advanced Wireless Research, from its beginning. PAWR is a program that's been spearheaded by the National Science Foundation with that has contributed $50 million to the program. There is a matching from a large industry consortium that has primarily with in-kind contribution contributed with to the program. And the goal of the program has been to create 4 city-scale platforms of advanced wireless research, testbeds, that will provide a diversity of testing and data collection opportunities for the community. Now, as of today, PAWR has awarded 4 testbeds. We are lucky enough to have PIs from ARA, the last one that you see on the right, which is the last one in temporal order to be awarded, just started very recently, with a focus on rural broadband and agricultural technology. AirPow was awarded about 2 years ago at this point, and it has a focus on 5G use cases with unmanned aerial vehicle and other mobility use cases. Cosmos, again, we have Ivan, so he's gonna talk about that. I'm sure he talked about that in the previous talk already. So Cosmos is in West Harlem with a focus on programmable architectures and programmable optical backhauls. And Powder in Salt Lake City, Powder Renew, focus on cellular architecture, virtualized architecture with programmability and massive MIMO throughout. And then last, as a PAWR affiliated platform is Colosseum, the world's largest radio frequency emulator, was developed by DARPA to support the Spectrum Collaboration Challenge, has moved to Northeastern at the end of 2019 to be opened to the research community as a platform for community use. Now, not gonna go into a lot of detail, but as of today, I think we have a very interesting, diverse, and sophisticated set of platforms. Again, Cosmos, Ivan will talk in more detail. Powder is a deployment in Salt Lake City of softwareized base station with some massive MIMO base station. It can be programmed and with a virtualized cloud infrastructure, so you can experiment with a number of mobile edge computing use cases, 5G, and the like. AirPow is really looking at the intersection between mobility, network robotics, and 5G and beyond wireless technologies. It was just AirPow just declared general availability of the platform last week, and again, it's open for community use. Colosseum, as I mentioned, we are currently managing at Northeastern. It can already support a number of very complex use cases with cellular networks, softwareized cellular networks, fully virtualized at scale with the ability to test and collect data from scenarios with tens of nodes. Clearly, lots of use cases in spectrum sharing, intersection between AI and wireless, etc. There's a number of local platform at Northeastern. We run and maintain the Arena testbed. Arena is an indoor platform with 64 antennas connected to the ceiling, connected all with coaxial cables to a set of software-defined radios on a rack that are fully synchronized and connected to computational capabilities in terms of CPUs, GPUs, etc. Now, all of these platforms are clearly diverse, interesting, enable a number of very different use cases. And what we've been trying to promote and propose is to develop pipelines where an experiment can be a data collection experiment, or it can be an experiment where you're testing specific algorithms, can on these softwareized platforms implemented and run on various different platforms. For example, you can design an experiment and design a complex scenario and test it on an emulated platform at scale in Colosseum. Then you can validate the experiment by moving a containerized version of the experiment to a real wireless environment, for example, in the Arena testbed at Northeastern. And then you can test at large scale on one of the PAWR platforms, for Powder, Cosmos, or now the AirPower is available on AirPower and soon on Era. So this ability to take a containerized experiment and run it over different platforms, I think it's crucial, and it's something that as a community we need to perfect and develop. Colosseum has a lot of tools that have been developed today, for example, for AI and ML related research, for data collection, for training of deep reinforcement learning agents. We've been doing quite a bit of experiments. I talked about it earlier this morning. So the ability to move some of the experiments and generalize data collection on some of the platforms is something that is really crucial. An example here, we have released a piece of software called Scope. Scope basically extends the capabilities of SRS Run for advanced cellular network research by providing capabilities like slicing and other control of various functionalities. And this is, it's something that we have already been able, for example, to test both on Colosseum, on Arena, and on Powder. And the behavior is consistent. These are experiments done with basically the same container run over different platforms. Another example is I talked about the work that we've been doing on developing XRun that are ORAN compliant and that can control the slicing and scheduling functionalities in a large scale softwareized cellular network. This is just showing an example of training agents based on offline data sets for traffic on Colosseum, and then doing online training on Arena, and you can see that we've been able to demonstrate, it's not publicly available in a paper yet, but that by pre-training on Colosseum and then testing over the air, the training time is significantly reduced with respect to starting from a clean slate agent that runs in an over-the-air testbed. So all these tools need to be, I think, developed and generalized. The idea is with this time, there's obviously a number of challenges with this idea of traveling containers. We don't have a common framework for experiments across platforms today. Every platform has its own syntax, supports the kinds of containers, so there is manual adaptation and troubleshooting, and that's fine. But I think we need to develop the tools to be able to move things around different testbeds. And there's obviously different interfaces to connect between servers and radios, different versions of the firmware on the same radios on different testbeds. I think putting some brain power in the community to try and find a common pathway to address some of these problems, I think could benefit greatly the entire community. That's all I had, Dimitris.
Thank you, Tommaso. We'll be able to get back to this issue of accessibility later on as well, I think. For the time being, Hongwei, would you like to take it over, please, and give us your introductory thoughts?
Sure, thanks. I have a few slides. Let me share my screen here.
Please go ahead. Yes.
So what I do is I'll share just a little bit more information about the Aero testbed. Since this is not open to the public, I just want to maybe set the context for some of the discussion, and then I'll share a few thoughts about, I guess, related to the key focus here about federation, I guess different dimension of federation as I can see today. So as we mentioned earlier, Aero is part of the PAWR program, and we just started the project a few months ago. In terms of basic objective, we're really looking at how we can potentially redefine rural broadband in terms of technology that's actually beyond what's available today. In particular, one of the key focus here is actually look at how you can develop technologies that can reduce the capex by a factor of 10 or more compared to today's solutions, so that you can actually make we can make rural broadband as affordable as urban broadband. And also in terms of use cases, besides looking at how we can get communities connected, we also need to look at the rural industry, such as agriculture. So this all actually impact how the era have been designed and will be rolled out in the coming years. So as a testbed, at scale testbed, this is going to be deployed in central Iowa, cutting across 3 counties, spanning an area of diameter about 60 kilometers. So the deployment itself will feature 2 layers of infrastructures. One is the aerial backhaul solution, which is basically consists of a set of links that actually consist of multimodal high-capacity wireless link. These are not fibers, but actually high-capacity wireless links that's going to be put together as a mesh structure, so that you can try out different experiments. And then at each one of these sites, basically include 6 rural cities plus a farm, we would have access network deployed too. And in the city of Ames, that's where the ISU resides. We have a little bit more denser deployment of access network at some of the crop and livestock farms, as well as city and state facilities, also including the research park, where a lot of the ag tech companies are located. Just a little bit, yeah, so there will be a pipeline, there will be a helicite that will become available around 2024. Just a little bit more detail about the platforms. For the backhaul, this is where you can find a diverse set of terrestrial and LEO SATCOM communication facilities, including a free space optical link that will be developed as a part of the project, which can offer capacity up to 160 Gbps at a distance up to 15 kilometers or more. There will also be middlewave and microwave long distance backhaul links used. So the testbed will be structured so that you can actually design solutions that can integrate all this diverse set of capabilities into a kind of robust, high-capacity communication backhaul solution. On the access network part, this is where we can find those both COTS and SDR-based platforms to support 5G and beyond type of research. For example, one of the unique platforms is the low UHF mice and MIMO platform to be provided by Skylark, which offers both production quality software plus programmable APIs. So the access network will be able to enable research, basically the whole stack research involving up to, for example, the spectrum-related research and edge and cloud computing. Besides supporting wireless research, there will be actually a major focus on applications too, so that we can actually integrate wireless networking solutions with applications in agriculture or education to study them in more kind of integrated realistic settings. So that's about the era itself. A very quick overview. More details can be found on the website. But let me actually share a few thoughts about the federation. For example, if I just kind of focus on era itself, I think what can potentially be feasible. I think there's a general. I feel there's a general opportunity for us to look at how we can integrate the physical deployment with virtual emulation, right? Well, this is what Tommaso have mentioned quite a bit today already, right? For example, we would love to integrate with ERA with Coliseum type of emulators, so that we can integrate, kind of have the benefit of both field deployment and simulation emulation. And also, I think there's the dimension look at how we can look at issues across the rural and urban settings, because the rural deployment channel properties and so on are quite different actually from the urban settings. Even within the rural regions, there's a huge diversity across farms and communities. So by integrating the different testbed together, this could allow us to study kind of similar issues, but in the different settings to enable, like, for example, regression testing across diverse settings. Besides just looking at the wireless itself, I feel there's even also the need and opportunity of looking at how we can integrate the wireless edge with the cloud infrastructure, right? Cloud testbed, for example, integrating the PAWR testbed with NSF cloud facility to enable end-to-end experimentation across edge and cloud. And I also feel that we probably also, as we think about federation and collaboration across testbed, we probably also want to go beyond infrastructure itself, right? One area that I have felt that could actually benefit a collective effort is actually to develop the production quality open source software that can be used by the broader research community, so that the kind of software we play with not just limited to labs and publications, but can also in the end be used in those real world applications. And this actually would really need a lot of manpower, right? It's not usually not a small group can deal with. I think that's where we can also collaborate. Okay, so that's all I have as a starting point. Let me stop there. Thanks.
Yeah, Hongwei, thanks very much. Just a quick question, maybe. Does ARA have a satellite component as well?
Yes, we have planned to include the LEO SATCOM user terminals at a few sites, so that you can actually use that together with other radio terrestrial platforms.
So you are working with a satellite provider right now to...
Yes, so we are talking to a few partners right now with SpaceX and OneWeb and a few other folks.
Great, thanks. Thank you very much. Ivan, you are next on my screen. Would you like to take it over and say a few things?
Sure, no, and I'm not going to flash any slides in the interest of time. I did show the Cosmos slide, so of course I can talk more about it. But actually, one thing that I wanted in the context of panel to sort of maybe discuss if you have time is the one thing that we realized doing the Zoran Plugfest is that there is quite a different approach to how industry looks at testbeds and how, especially at the federation of testbeds that industry is talking about, versus how the academic community and our all usual conversations about connecting testbeds and what you can do by sharing resources, right? And so it's obviously clear that there are all sorts of issues that we are not addressing that industry is quite interested in. And at the same time, they're much less open in terms of what they're allowing and what are the policies. And so therefore, it appears that one discussion that we are sort of usually skipping over is how to define policies and what are the expressiveness of the policies that we need to be able to articulate in federation environments. And so, to me, that sort of looks like something that we as a community should start addressing. And that's literally where I would stop. And of course, I can talk about testbeds. But
great. Thank you, Ivan. Thank you very much. Casey, I see you're somewhere in Florida maybe right now. Would you like to take it over? We cannot hear you. Just unmute.
Dimitris, you don't look like you're in Florida. What's that background instead?
That's yes. I'm in a dark office actually right now, hidden somewhere.
Maybe he just wishes he's in Florida.
Yeah, I wish I'm on the beach. But let me share my slide. Is that showing properly?
Yes, and if you can, yes, perfect.
Sure, I'll just go through quickly. I think to many friends in this community know a little bit about Fabric. It's an NSF mid-scale research infrastructure built across the nation as a future internet testbed. But NSF explicitly expected us to facilitate the creation of this concept, a testbed of testbeds. So quickly show when we envisioned Fabric, we are thinking about the computing continuum, where all these different edge 5G and different computing infrastructure, all the way from the core, the cloud, very high performance computing facilities to IoT devices. So within that continuum, in the past, network is just a connector in between. But now with the evolution of technology, networking instruments can actually be highly computational. So that's one effort that we put in. We try to create Fabric as a very capable computing infrastructure that goes along the national network footprint, and we're building that on top of the Department of Energy's latest national backbone. So now I'll quickly show our topology plan. There's 29 sites within US, and then we already started to connect internationally to Tokyo in Asia, to Europe. We connected to Bristol, their smart city efforts. We connect to Amsterdam, and we connect to CERN in Switzerland for high energy physics research. We also connect to South America, working with Brazil on weather research. So one thing to point out for this community is we're connected to the PAWR testbed, the Cosmos testbed, and as of right now, the Utah installation already has concluded. So we are working on turning on the connection between Fabric and PAWR. And then one important question that we are discussing is what should be the model of identifying the right experiment that should leverage Fabric to go across these wireless research instruments. So with the PAWR testbeds, we also have the city scale 5G testbed in Bristol, UK. We have a 5G testbed in Tokyo. They're all connected. They're all very eager to enable research across them. But the big question is, what are the right type of experiments to begin with? And I think Tommaso's talk today, with Ivan's talk today, talk about how ORAN really opens up that dimension to think about how, as you're supporting in the future, say for a city, this 40,000 base stations, I'm sure you don't want that control to happen at the base station level. You probably don't even want to make it happen at just a community or a city level. It's easily a large number of control entities, and then so there will be a push towards aggregation of these control to cloud and sort of centralized compute. So how can that happen? I think Fabric can help enable those kind of experiments. So just quickly for this community to see the kind of resources that Fabric will provide typically. So we build directly on top of the optical interconnect. So we can work on top of DWDM optical links. Most researchers will probably want to have point-to-point networks. Basically, we enable that through MPLS circuits. And that gives us the control of quality of service. So if you care about the certain bandwidth, certain latency, that's something that we can provide, repeatable. It can also, right now, for example, we're still building up the optical direct support. We go over Internet too. So these are static VLANs already allocated across the nation. One big difference from the compared to the past is in the past we depend on the sort of the fortune of Internet to having enough of the VLAN to support a reservation topology, but now those VLANs are static. So we directly run across that, and then so it's much more predictable. We pair at layer 2 and layer 3 networks. Within Fabric, we have this IPv4 and IPv6 experimental topologies. With the public internet, we have IPv6 pairing. So ESNet and Internet 2 help us provide the commercial network interface so we can do experiment across the testbed and the public internet. And then we see experiments as building blocks. So you basically identify the network, the compute resources, the locations. And then once you have that, the most important part is how do you put those resources into the topology you need. So some experiments will want to do inline processing. So we have this bumping the wire model where every network node in Fabric is basically looking like this. So you have some compute entities you can reserve. You have NICs that can be reserved. These are smart NICs. You can use it as just regular NICs, or you can actually go in and program whether it's OpenFlow style SDN, or you can, there are some additional APIs that you can control that differently. We also have PTP, highly disciplined timestamp, which you can do packet tracing, and that's a popular feature people talk about. With the Smart NIC, you can, this is Connect X and 5 and 6 cards, if you're familiar with that. With the FPGA and P4, that's also element going in there. So we actually have an FPGA development right now. There's a researcher that is going to enable P4 switch on top of an FPGA implementation. But at the same time, we also right now support the software simulated P4 if that's what you care about. In-network AI, machine learning is a very important use case that Fabric supports. So we really focus on how do you enable the data flow going easily into the GPUs or the FPGAs for your workload. And finally, connecting to external facilities. Again, layer 2, layer 3. So all the testbed partners here. I think we already have many discussions on pairing our experiments together. So that's something that perhaps that'll be the first point. And to, for example, with PAWR, since the facility is already sort of having this VLAN type of experimental topology, that's one discussion to directly map a VLAN into Fabric. And then public clouds. So both NSF clouds, Cloud Lab and Chameleon, are directly connected to Fabric. And then we go through Internet 2 to connect to the commercial cloud providers. So those are there. And then experimenters' own resource. So a lot of on-campus testbeds or your own research machine, we can map VPN and VP wires into that. So in summary, I think right now we have a production testbed already turned on. We have a soft launch. Basically, a lot of features are still under development by NSF requirement. We will conclude building everything by 2024. But right now, the early features is already there. There are many early experimenters are already using that. We start to observe how where people will need help from the community to say what is a good experimental model. And I hope this discussion later can give some ideas to that. Thank you.
Thank you, Casey, very much. Thank you. And Serge from Paris, would you like to take it?
Hello. Good to see you.
Good to see you too.
I guess you see my screen, right?
Yes, Serge, please go ahead.
Yes, excellent. So let me just take a few minutes to share my own experience with test facilities. And just to consider the things that evolved and how we could eventually, as a community, consider the next phase. So long ago, there were some facilities that have been designed for really addressing very specific, although quite broad scientific problems. So for instance, you see Planet Lab here, and we started again this concept of federation that is maybe poorly defined here, with federating resources just to scale them up between what was done in the US and what was done in Europe, and so on and so forth. And of course, thanks to Ivan, among others, then other type of testbed addressing different type of problems, different type of communities have been designed as well. And of course, they have been very impactful because as a community, we were certainly lacking tools in order to provide evidence about the work that we have been doing. And then we started to consider how we could scale them up, either with the amount of resources that we made available to the community, or through diversity of resources, because the field has been evolving from, let's say, quite fragmented type of systems into more diverse type of environments. So this was the time of the US Genie infrastructure, basically trying to develop a nationwide programmable infrastructure in order to experiment with, let's say, new potential design of the internet. And in Europe, we had the FIRE initiative, where the idea was a little bit different, trying to aggregate different type of resources to make them available to a single experimenter. This was nice. A quite reasonable amount of funding has been thrown to those problems. Again, this federation approach was very useful in order to raise awareness, either to the stakeholders, either to the community, as well as to start sharing different kind of approach, API tools, and so on and so forth. But maybe I will join Ivan's comments, although I've been pushing federation very strongly in the past, that maybe these days this is not the right way to go. It doesn't mean that I do not fully support what was mentioned by Tommaso, which is the fact that actually, because you need to have reproducible experiments, it's very useful to be in the position to replicate your experiments on different type of, let's say, diverse facilities. So now we heard about new generations. I won't go into the details, but you see here initiatives, of course, from the NSF, and congrats to ARA, the new one in PAWR. Welcome, and of course Fabric, Bridges, Colosseum, and we have other type of infrastructures that have been designed in the US and in Europe with maybe slightly different flavor. But what I would like to share with you now is my experience when I started to really consider those test beds in order to scale them up as scientific instruments. And in Europe, you have actually a framework, an organization, which is funded by the European Commission, which name is ESFRI, where basically all communities, all scientific communities, so it could be biology, of course, high energy physics, but also humanities, they go there in order to get funding with respect to designing a scientific instrument. So they always start with a scientific question. So for instance, does the Higgs boson exist? And then if you found that the question is sufficiently interesting, then eventually you will go into a phase where you will, I will show you, have a very thorough process in order to go from the design to basically the démantèlement. The thing which was quite surprising, actually not very surprising, but is that if you look at the groups that actually were organizing ESFRI, you see energy, health and food, environment, social, physical, but nothing dealing with digital. Because for all those sciences, actually, you don't need anything in order to support the research in digital sciences. What you need is a digital infrastructure in order to support e-sciences, which is, of course, completely different. And we started to discuss with the stakeholders of ESFRI. It's quite complex because you have to talk with high energy physics, biologists, and so on. But we succeeded in 2018 to make them open a data, computing, and digital research infrastructure. It's a big, big step forward because for them, it was not necessary. Because as a matter of fact, you could use whatever exists out there. And there are also instruments that are funded by ESFRI, like TRACE or Géant. So Géant is not only funded by ESFRI, but that basically will provide you with the infrastructure that you need. So what is interesting is that actually we learned a lot about what they define as a scientific instrument. And there is a very well-defined process going from the concept, so what is the scientific question, to the design, so basically, do you know how to build it? Then you move into the preparation, which is the full design space, including the technology, including engaging the community of the research infrastructure, and then you can jump into implementation. And once the thing has been designed, so the telescope is ready to go, then you can move into operation and eventually termination. And usually this cycle that you see lasted 15 to 20 years. That's basically what you need to launch that kind of system. So it was very difficult for them first to understand what are the scientific questions that we address, because it's not something which is like a physical environment. And it was also difficult for them to understand the time scale that we have to deal with to be relevant. So nevertheless, we succeeded this year to have this new initiative named Slices, which is now on the ESFRI roadmap. So we are moving into that space. We are in the design phase, and we are now going to move into the preparation phase, where they very tightly monitor us to check whether we have reached these minimum key requirements that they consider. Some of them are technical, others are more political, because it's a big umbrella that has to be fully governed by the different stakeholders. To be competitive with other sciences, we expect it's relevant, to bring together communities from wireless, cloud, edge, radio, and so on and so forth. And this is a difficult exercise because so far, if I consider what you guys have in the US, still you have a quite separated framework with respect to cloud on the one hand. So for instance, Chameleon, Cloud Lab, and so on. And let's say 5G beyond 5G and 6G on the other hand. Although basically the equipments and a large part of the software components eventually could converge. So it's something which is a bit tricky, but if you want to have the scale of the community to compete with high energy physics, this is what you have to do. But again, what is really, really interesting is that you have to convince them that you will have the scientific methodology in order to make successful the discovery process. So this is what we have today. It's of course, a distributed infrastructure that will be fully programmable. We have, let's say, 2 years before we enter into the implementation phase. So we are a little bit further than the design. But within ESFRI, what they call a research infrastructure, a distributed research infrastructure, this is well understood by ESFRI now, although it's quite new for them, because in the past you had to go on site to do your experiment, is that it has to be centrally controlled and it has to be fully integrated. And this is also one of the reasons why I start to evade a little bit from the federation, where we had to federate different things that eventually were not fully relevant. So the system has to be fully integrated with respect to the scientific question that you plan to address. Also, of course, the implementation can be distributed. So that's a kind of architecture that we are considering, not very far from some of the thought that, of course, you guys have been presenting, and especially Ivan in his presentation. And last but not least, if you go to ESFRI, it's impossible to evade, escape, or not consider open data and reproducibility. For them, it's a scientific mistake. So it's completely integrated in the infrastructure, the principle that actually you should be able to collect data. You have to explain what type of data will be collected from the infrastructure and how you will make this data available. And actually, they even go further than that, because there was another initiative that has been funded by the Commission, which name is EOSC, so European Open Science Cloud, which is not a cloud per se, but it's a repository for research data coming from the different scientific instruments. So meaning that for Slices, we will have to make sure that we have a repository of data that has been produced by the community in order to make it available the whole community. So again, it's really interesting to see how they look at a scientific instrument. And I think that first, with respect to the methodology, we can learn a lot. And with respect to community, there is a big difference, because in many other scientific domains, experimentally driven data is a must, and it's highly considered or highly recognized. So that's something that I believe we have also to consider. I, of course, fully understand the expectation from the industry, but as an academic, I don't think we have to oppose them, but I think that we have at least to make sure that the methodology and what we produce as a community will be in a position to, again, provide evidence as a major outcome. That's it for me. Thanks for listening.
Thank you, Serge, very much. Quick question, is the European cloud repository that you mentioned active right now, or it's planned for the near future?
Well, it started 4 or 5 years ago. Of course, okay. It's a very complex system. So for the moment, they have been basically designing the baseline infrastructure, which is, let's say, the infrastructure in order to host. And of course, now they are using projects from different domains in order to understand how you're going to structure the scientific data. And all this data is going to be made available at large. And this is why as soon as you want to enter into ESFRI, you have to explain how you are going to interoperate with yours. Otherwise, there is no possibility for you to enter into the first phase.
Very good. Thank you, Serge, very much. Let's see now, guys, what questions we have. George, would it be possible to post for us the first set of questions that we have?
Sure. You should all be able to see my screen with the first questions that we had prepared for the panel. I believe there has been some discussions ongoing during the introduction of every panelist, but
right.
Maybe
so
we can go in more detail.
The answer questions goes as follows. What are some of the major test beds that we have today? What is their accessibility status? We've discussed that quite a bit already, but maybe might be more interesting to briefly see what lessons maybe we learned from those major US and European Union test beds. What went well, what maybe not so well, and what maybe we need to reconsider for the future. Any of the panelists?
This is a question for Ivan, and nobody better than him.
So Tommaso, you are volunteering Ivan for that, you think?
I'm volunteering Ivan, yes.
Okay, Ivan.
Thank you, Tommaso. I don't know. I mean, yeah, sure. So the first two are we talked about, right? So the third one is actually what's really interesting, right? And yes. And I think Serge can also share. We went through, and not just Serge, Casey as well, and Tommaso as well, right? So we've been using testbeds for a while, and we think. So one thing that I think we learned is that herding cats is hard. So every testbed is still different, meaning uses somewhat different tools. There is some harmonization that we are doing, at least in certain components of the testbeds. But when it comes to actually running experiments, unfortunately, each testbed has its own way of running experiments, which means that you have a learning curve for each one of them. That probably is not that bad, but hopefully we can do something better. I think that still in terms of federations and what we are doing with the test, how we federate testbeds, still has a lot of things that we need to iron out. I jokingly always say that our spec is sort of still our lowest common denominator in describing what we have, and our spec is really old by now, so we really need to come up with the better tools to find out what's available and how to get access to it. And then, of course, the main idea is to is there a way for us to federate to a point where things are more common, right? And I don't know. This is something that's been open forever. So I don't know if others have any input on that.
Ivan, may I ask you, well, we use the term federating, right, and federated test beds. For you specifically, like for you, what do you think qualifies as a federated collection?
Well,
what makes it federated?
Yeah, so on the lowest level, right, meaning when I'm talking about lowest level, I'm talking lowest level of federation. You want to be able to access a testbed, right? So that's the sort of, okay, I need to access Colosseum, therefore I need to be able to log in into Colosseum. Now, federation means that, okay, I don't need to go through calling Tommaso on the phone and asking, hey, Tommaso, can somebody make an account for my student who's going to do something, right? It's sort of some sort of automation on that level, but that's really the lowest common denominator of all the federation levels. And at the other end of the spectrum, you have the sort of, oh, I'm writing an experiment, let's say Jupyter Notebook experiment that's going to connect to 6 testbeds simultaneously and create some really complex beamforming experiment in Cosmos, where powder massive MIMO will be used for some virtual 4G channel, and millimeter wave in Cosmos will be used for 5G channel, right? That is, of course, the big question is why would anybody want to do that? But I'm just, is a concept, right? Being able to run an experiment that transparently uses all the testbeds. And the big question is, do we really need that? But that's a separate story.
Yes. Does anybody else from us want to take a shot at this question, lessons learned and things that we should be doing differently in the future?
Yeah, this is. I just wanted to add to what Ivan said, that I think there is an intermediate step, which is what I was more trying to articulate in my talk, is where, you know, maybe you don't have a common control. You can't really run an experiment simultaneously on multiple testbeds, but you have a set of tools through which an experiment that you run one testbed, you can somewhat easily port on a different testbed. And that has to, you know, that I think is helpful both in terms of data collection, certainly if you're doing machine learning related work, but also for, you know, testing an algorithm. How does it work in different environments under different conditions with different channels at different frequencies, things like that.
Great. Yeah, thanks, Tommaso. George, maybe we can move on to the next question that I see in front of me that actually relates to the issue of multi-testbed, cross-testbed experimentation. And I think Ivan mentioned that already. Is there a need for this? What kind of scientific questions do you think can potentially be answered that way? Going cross-testbed or multi-testbed? Is that something that matters maybe, or it's just not so important? What do you think? Ivan, I see you're nodding. What do you think?
Well, so I don't want to monopolize this. Others should be feeding their input on it. It's very hard, and we've been trying for years to come up with a really interesting experiment that will span a large space. And other than experiments of the type of Planet Lab or Fabric, meaning that you are really looking into internet scale type of experiments, it's really hard to imagine a single experiment that would use all the or multiple facilities. That is not to say that we don't need the means to discover what's available, and based on, say, a type of experiment one wants to do, being able to run that experiment on a particular testbed. That would be the great achievement if we could come up with it, right? Think in terms of whether it's a single portal or, you know, as I said, Jupyter Notebook, some sort of a distributed portal where if I sort of say, oh, I want to do massive MIMO experiment, it will send me to PAWR and maybe even abstract my description of the experiment through some sort of a scripting or other means and execute it on a testbed and deliver me the results even without me having to interactively deal with a testbed. But that's a long shot. I mean, that needs a lot of work.
Yeah, thanks, Ivan.
If I may maybe comment on this. When we started, again, I mean, the issue is that you need to throw a lot of resources. And it was very difficult for us to build something which is, let's say, hopefully sustainable. And also because most of the questions were about the scale and about, you know, the diversity of resources. So basically federation, to come back to the previous question, was a means for us to open up resources under the control of other authorities. So as Ivan said, it's the minimum set of functionality that you need basically to enable access of user under one authority to the resources under another authority. Now, it all depends on the scientific questions, because we are always asked by the stakeholders, or you need to demonstrate experiments across the Atlantic or across test beds. I think maybe even if we don't come up with such experiments, it is a matter of the community. So the reason why, again, we are interested in interconnecting with the US is that actually we can really engage the whole community into understanding what does it mean to develop such a facility. So it's exactly what high energy physics is doing. It's exactly what biology community is doing. So I think it's very important, even if actually it's not always obvious to understand what those experiments are. And this is why I think we went too far with federation, trying to federate things that are not relevant. And this is why I believe that we need to have an approach where we can aggregate resources that are, let's say, under different domains, but with a more coherent and organized approach.
Great. Staying in Europe, maybe, Mohammad, if I may ask you, because I know you have worked on 2 different 5G test beds. You have worked on the 5G urban test bed, I guess, in UK, and you also worked on this 5G connected forest project, right? I'm kind of curious, are these 2 different test beds? Is there some connection there? Is some sort of cross test bedding experimentation going on, or maybe possible?
Sure. I was thinking to talk about those 2, how they're different and why we really need to share 2 cross test bed activities, really. Our Urban Connected Community Project, what we try to do, look into the health application and connected autonomous vehicle applications. If I consider the early stages, what we try to look into, both of them, UILLC requirement is quite high. So if in medical application, for example, we want to do teleoperations, of course, we do some experiment of that kind, but for medical application, we have to do 2 things, EMBB as well. For example, imagery transmission as quickly as possible, how close the real time we can do. At the same time, teleoperations. That's for medical applications scenarios in the testbed. At the same time, when you go to connected forest community, we try to utilize this kind of high-speed 5G capability. How, for example, we built an entertainment pod where in Sherwood Forest, Robin Hood comes up with AR, VR experience. So we have a lot of visitors coming in to see digital Robin Hood and then see all the children in their school holiday, they become excited into this. Now, if I come back to this question, particular one, is there any need to multi-test bed, cross-test bed experimentation? I would say yes, in our context, because each test bed had its own characteristics as the way built. At least I can say for UK context, when government funded a particular test bed, we have certain requirements. As we have IR, for example, that would be for agriculture applications specific. So if we're going to consider this kind of cross test bed experimentation, one has UILLC, other one is EMBB dominant. How about putting them together? Or if you think of agricultural scenario, we need to operate those kind of tractors or the machineries in real time remotely. The latency requirement there would be relatively different than if you want to run an operation. Now, we want to see in larger scale, different general condition, how can that particular kind of experiment can give us sustainable, scalable outcome. Now, the second part of the question I can see here, what scientific question can potentially this answer this way is actually sustainability of certain model. We can experiment if it is scalable, highly scalable. We can, for 5G's context, we are having MMTC, EMBB, ULLC, mixed output. If you have particular application, we need two of them. We need to share resources from characteristics from two different testbeds and see the model that we build up, how sustainable that is. Then we can optimize. So literally, from our perspective, what we've learned last 7-8 years, federation, if you want to go beyond 5G, there's no other option. I don't say no other option as an absolute. Federated approach would be one of the easier way we can go to the next one. That's what I would put.
Thank you, Mohammad. Maybe it might be time to move on to the next bunch of questions, if at all possible, George, for save time. Yeah. So, right, it's about federations of testbeds, if it makes sense or not. I guess the core here is the incentive matter, right? What kind of incentive would a testbed host have to join and maintain a federated lab testbed? Do you have any thoughts about this? Let's say, Hongwei, may I ask you, what are your thoughts personally about federations of testbeds? And if you think that it's something appropriate, how would you motivate, let's say, how would you motivate testbed owners, so to speak, to participate in a federation?
Right. So yeah, it's actually, these are some interesting questions. I think the questions are posed more from the perspective of the owner or testbed developer. I think there's also the similar question that we were talking about earlier about the users, right? Are there use cases? I think it's the same question that can be asked from that perspective. Actually, I might take on, I think, on all these three questions so far, right? I think need is there, but the question is really, is the benefit weigh outweigh the pain to do the federation? And if you look back in the history, in the not so long, like look at Gini, and there's not much federation within Gini itself, right? I think even though we have tried very hard. And if you look at from my perspective, right, what I can tell, looks like one of the fundamental reasons for not having a truly functioning federated testbed with convincing use cases is actually software, right? There's no reason why this hardware cannot be federated, but the software was not, in a way, not interoperating. It's not designed in a holistic way. And then if you look at the reason for that is because of people who write those software, right? There's a legacy there. I think probably in terms of coming back to this question, right? How can we reduce or minimize the barrier to develop federated testbed, and also how to make it easy for user to use, right? Even though usually each experiment only focus on one specific question, right? That may not need the whole thing, but there are certain integration efforts that may be there. So I think there's a strategy we can look at as a community. How can we address the challenges we face today? One thing I can share, one personal story here about incentive. As we develop ERA, we end up having to really study hard on what software platform to use as a basis of development. So in the end, we actually worked with the Communion team, and so that we can leverage the open source software they have been leveraging, like OpenStack, right? So that's actually one. So that, for example, today I feel there's actually going to be very easy for us to federate ERA with Communion because we use the same software framework, and also we all use the same open source software framework used by the broad industry. So I think for us as a community, if we can reduce barrier to entry for us as developers and also for users, that'd be great.
Good, thank you, Hongwei. George, I think we have to move to the next bunch of questions. And this now set of questions looks like this. What test beds are we missing today? Can new specialized test beds help advance theory and practice of networked AI and connected robotics? How about RF convergence? How about next-G wireless with resiliency and incorporated distributed computing? So basically, the question that we face here is what are we missing today? What should we see being done tomorrow? And how do those test beds relate with issues such as AI, RF convergence, and resilient next-G? Casey, would you like to take it over if you don't mind at this point? Give us your thoughts about any parts of this question.
I'll probably integrate this question with all the earlier question. I'll offer a different approach to think about this is thinking about the measurement on any of these test beds and then how those data will enable the scientific discovery. I think in the early experience in Genie, we built the system and then NSF start to see there's not a lot of new researchers coming to use the system. And then we're like, people are not using that. It's like a chicken and egg problem. We need to convince them there is the possibility of finding new insights if you change your way of thinking about your problem. So we start to ask them, what are the things that you can measure on the testbed that you do not measure in your current either simulation approach or your local testbed? And then once they start to think about that, then new ideas come out, and then there's the research programs are starting to fund these pilot experiments so that they'll actually try it out and see whether they really see major differences. So I think in the multi-testbed question that we have right now is, I think Federation doesn't have to go all the way to full software integration, but rather, if you think about a scientific problem and think about that as this end-to-end continuum, how can you map a problem you're looking at onto the number of test beds that's available there? Even if you don't physically connect them at the very beginning, you should be able to, researchers should be able to map their problem into these parts. And then we go down to look at what are the minimum support needed so that you can do measurements on these different test beds and then make sense of the findings. So like Yvonne said, the lowest denominator is having people to access them. And then the next thing is probably just being able to connect. We don't have to have software, complex software development for them to connect. We can map it at a network level. The resources are there, and that you can provision experiments on 2 or 3 different test beds, but we know that they are interconnected so that the measurements make sense. So that's my offer. Think about the kind of new data measurements that are important to the domain problem. And then the second part of that argument is, how do you think about sharing those data? I think a lot of the discoveries come when these measurements are presented to a broader set of eyes. You may have some ideas that prompted you do certain measurements, certain experiments, but if those data can be systematically shared with a broader range of researchers, there will be new conclusions coming out of that, or new challenges coming out of that. So that's my offer. I think there are the testbeds activities in all these different components that we listed out. So I wouldn't say there's an easy answer to say what is missing. But once people start to think about what are actually generated from the existing testbeds, and if we help them to design experiments across testbeds with sort of the least efforts needed, that may start to find answers to this.
Thank you, Casey, very much.
I wanted to, Dimitris, if on this various question, right? I mean, I wouldn't say that this is all covered in existing testbeds, but you know, network AI, connected robotics, that's really what the North Carolina State Air PAWR testbed was conceived for, you know, mobility, use cases, control mobility, and etc. So the scale is still limited, but I think there is a lot of very interesting experiments that can be conducted today. So if you're interested in that, check that out. AirPow, go visit them, talk to them, let them know what you need, because they're in they're collecting inputs from the community to understand also what they should be supporting. On RF converts, com sensing localization, I would say that both Cosmos and PAWR can support some experiments. Again, maybe not everything that one would want to do, but there's a lot that can be done, and you can, in many cases, bring your own hardware. And the wireless resilience, again, I think PAWR and Cosmos and even Colosseum can offer a lot in terms of capabilities in these. It's not to say that everything is covered, obviously, but I think as a community, there's quite a few resources, and the more people use them, the more people become aware of them, and the more interest there is, and we're gonna just have more resources for that.
Great, yes, thank you, Tommaso. Maybe staying a little bit on the AI matter and wireless and testbeds. Surely AI can help with the progress of wireless, but at the same time, wireless can also help AI, right? In many ways. So surely AI can optimize your network, but any system of connected AI modules, robotic or not, need a network, right? And that's kind of a really specialized network now. And maybe there are some opportunities there to investigate how wireless research can now help advance AI as of going the other way, basically. So going back to that, Tommaso, you think that the North Carolina State platform can help us a little bit in that direction? If you can elaborate a little bit.
Yeah, obviously it's complex. It's a complex question, but yeah, certainly, AI is evolving certainly in the direction of having distributed intelligence and federated intelligence. I would say that all of the testbeds that are available today can help in that domain, developing solutions that can be robust and that can be generalized to different environments. So it's the diversity in terms of environments, channels, and deployments that you have across these platforms, I think can play a very important role into developing models that can be generalized.
Thank you, Tommaso.
Yeah, that's a topic actually which is being addressed by different communities. It's at the crossroads of AI, cloud, edge, IoT, and actually that's why we need also to understand how this is going to affect the platform that we're developing. Because, for instance, there are a lot of questions that are really end-to-end. How are you going to organize the processing of the data with respect to machine learning in the device, in the end device, in the edge, in the cloud, assuming differential privacy, and so on and so forth. So this is why you need to have this coherent set of resources that actually you can engage in order to understand what are the different design space for these kind of problems. It's certainly a very important topic for us to get prepared. Otherwise, we will miss some of the important questions.
Thank you, Serge. George, I'm wondering if you have any questions that you might have been able to curate from the audience for us.
We are well within the break. I believe we are eating the first 5 minutes of the break. But if there is some time, we can maybe take two questions. One question that came up was if can someone speak to the comparison of issues related to creating your own systems infrastructure for federation, even if based on open source, versus using commercial infrastructure and software such as cloud computing resources?
Yeah, Casey, I saw you. You want to say something about this?
So one use of the word federation in the NSF Cloud Lab context we have several federated Cloud Lab installations that's not part of the NSF supported Cloud Lab infrastructure, but they use the same software stack to enable their testbed, and then they are loosely federated. That is, you can actually see them, but then they're not exactly open the same way as the official Cloud Lab site. So I think that basically means if there are certain testbed software stack that can be shared, it will enable the community to build up a sort of more specialized local testbed, but reusing the community resources out of the goodwill of either the developer or out of some NSF support to be able to do that.
Thank you, Casey. And maybe one last question, George, before we take a break.
Sure. The last question was that 5G and RAN have many applications, like the ones that we have been discussing. Each testbed focuses on one of those applications. The question is, do you see the available testbeds evolving to incorporate all of these? So, would anybody want to take that?
Yes,
Mohammad,
sure.
please go ahead.
Shall I take that?
Go ahead.
That's exactly the kind of thing we need federation for, because government invested different testbed, at least I'm talking about in the UK's perspective, especially into particular kind of applications. So we can generate network behavior of that kind of network operation of that application and user behavior. Other one, we're doing the same thing. And this is why we wanted to see the right set of API to connect those two testbed together, security management, resource allocation, so that whenever we need to mix them up with that API, we can do experiment of this kind, a mix like EMBB or URLC, either both of them together or all three of them together, if it is needed. There is not many applications of this kind, but who knows, 5 years down the line, we'll have mixed use cases of this kind.
Yep. Thank you, Mohammad. Any thoughts by any?
I think actually, if I may just chime in, I think actually quite a few testbed can support all three use cases already, I would imagine, because there's all software-defined radios, right? And even for like for ERA, we have actually looked at all this spectrum of experiments that include what has been mentioned here too. So if you check it out, I think it's actually you can do many experiments already.
Great. Any other concluding thoughts by anybody from the panel? Any panelists?
As I am the only one from Europe, I would like maybe to throw a question to you guys. So if I take the PAWR nodes, so now you have 4 of them, and I'm sorry I arrived at the end of Ivan's talk, so I could not follow this picture where I saw some kind of integration. But my question is, how much do you plan to share or integrate with respect to those 4 platforms that have developed, let's say, almost at the same time scale, but a little bit shifted in time? And I'm sorry if you don't like the question, I can take it back.
It's okay, Serge. Would anybody?
I don't know. I mean, I'm not sure why I'm taking this, but I think we should harmonize this somehow and figure out, if nothing else, how to share data and stuff. But we failed miserably in the past because of IRBs, and I still don't have a solution for that. So we have to somehow address this on a much higher level, and I don't know, maybe Tommaso wants to take that one up. But I don't see a problem. It's just a question of somebody pushing us to do it, right?
Tommaso, what are your thoughts?
Yeah, and more than pushing is the aligning the objectives and making sure that it becomes a priority for everyone, right? Because that's that's what's tough sometimes in academic environments where we all like to do our own. That's the beauty of
hard, yeah.
Right. So that's in terms of I think sharing. The hardware, obviously, it's hard to share, right? It's at different locations. Software, there's an element of sharing software already, I would say, for sure, across the platforms, and of sharing experience, best practices, data sets. We're trying to now, in a little more coordinated way, push the sharing of data sets. And so we're, there's a few things that are happening. I think we can certainly do more going forward. But yeah.
But thank you, Tommaso, very much. We have to close right here. Thank you all. Thank you, Serge. Thank you, Ivan. Thank you, Hongwei. Thank you, Mohammad, very much. Thank you, Casey. See you soon, hopefully somewhere.
Thank you all.
Thank you, Dimitris. Thank you all.
Yeah.
Thanks, guys.
Bye.
Bye, everybody.
Back to you, George. Take it over, George.
Bye.
Thank you, everyone. Thank you for the exciting panel. With that, I'll hand it over to our host, the new one, who will lead us into the very much needed break. Zhang.
Thank you, George. Thank you all very much for the interesting talks and also panel discussions. Next, we will have a very short break. We'll come back at 2 p.m. EST, back to the keynote session. We'll see you soon.
Hi, hello. I just kind of wanted to test if you can hear me okay.
Yes.
Okay, just